Hey y'all, I wanted to make a video for you. I know that it was fast and furious at the end of class today. So I wanted to go through these examples of graphing a transformed tangent and cotangent function again with you, just in case you needed a little bit more explanation or just in case this is helpful for you. Um, so to graph a transformed tangent or cotangent function, the first thing you're going to do is calculate the period of your transformed function. Again, the period of a transformed function is going to be the period of your normal function, which for tangent and cotangent is just pi. And then you're going to divide by your b value, which is again the number that's being multiplied by x inside your tangent or cotangent function. So the period is going to be pi over b this time because the period of normal tangent and normal cotangent is just pi. And then once you calculate the period, you're going to basically calculate the location and graph your vertical asymptotes. So for tangent, you're going to go um, right and left half your period from 0, and that's where your asymptotes will be. So again, that's going to be positive pi over 2b and negative pi over 2b. That's just positive and negative half your period. And then for cotangent, you always have a vertical asymptote at 0, and the other one will be at x equals whatever your period is. And then once you know where your asymptotes are, you are going to put an x-intercept halfway between your vertical asymptotes. You always have an x-intercept halfway between on both tangent and cotangent. And then once you have that, we just have to figure out whether these things are increased from left to right or decreased from left to right. Instead of trying to memorize which one does which and whether you have to flip it upside down or not, I think it's easier for your brains to just pick an x value and plug it into your function to get the y value, and that'll tell you what your function does. So you're going to choose a convenient x value. This says on both sides, but again, you really just have to do one because we're going to use the symmetry of this function to help us do this. So you really just have to plug one x value in. And then, so you'll pick that x value, plug it into your function. That will tell you what y is, and then you can fill in your function. So let's try this. We'll start with number 1 here. Y equals 1/2 times the cotangent of 2x. So again, y equals a times the cotangent of bx is our general formula here. So a is 1/2 and b is 2. We're going to use that b value of 2 to calculate the period of this transformed function. The period is pi divided by your b value, and here our b value is 2. So pi over 2 is our period. Okay, so now that we have our period, we're going to use that to figure out where our asymptotes are. This is a cotangent function. So that means for cotangent, I'm going to switch my colors here. Cotangent always has an asymptote at x equals 0. And then the other asymptote is going to happen here at the end of its period. The period is pi over 2. So the x value where this other asymptote is going to be x equals pi over 2. Those are your asymptotes. So once we have our asymptotes at 0 and x equals pi over 2, we are going to put an x-intercept halfway between. So we're going to have an x-intercept halfway between, and the x value halfway between 0 and pi over 2 is pi over 4. Sorry, struggling with saying one thing and writing another. This is pi over 4 here in the middle. Now, to figure out whether this thing goes down from left to right or up from left to right, we're just going to pick a convenient x value and plug it into our function. I find it's easiest to pick a positive value halfway between your x-intercept and your asymptote. So for us, that's going to be right here. Halfway between 0 and pi over 4 is pi over 8. So I know this x value is pi over 8. And I'm just going to take that x value and I'm going to plug it into our function to get y. So again, our function is y equals 1/2 times the cotangent of 2x. So we're going to go ahead and plug pi over 8 into this function. And we're going to get y equals 1/2 times the cotangent of 2 times pi over 8. Well, that's 2 over 1 times pi over 8. We have to simplify inside our parentheses here. So that means this is 1/2 times the cotangent of 2 pi over 8, or I can simplify that to pi over 4. So this is going to be 1/2 times the cotangent of pi over 4. Okay, so to find cotangent, we're going to go to our unit circle because pi over 4 is on our unit circle. Pi over 4 here, the ordered pair there is root 2 over 2, root 2 over 2. To calculate cotangent from an ordered pair on the terminal side of your at angle, you're going to do x over y. So the cotangent of pi over 4 is root 2 over 2 divided by root 2 over 2. Root 2 over 2 divided by itself is just 1. So that means when x equals, sorry, again, struggling with saying one thing, writing another. So when x equals pi over 8, y is 1/2. So I'm going to go to my graph. I know that we have a 1/2 y value when x equals pi over 8. And we can use symmetry then, because really we want, Alex is going to want an x value on the other side as well. And so on the other side, halfway between pi over 4 and pi over 2, this is 3 pi over 8. And with a symmetry, basically, since pi over 8 went up, 3 pi over 8 is going to come down the same amount because these functions are symmetric. And that means that this thing decreases from left to right. And that is one cycle of this graph, and that is all that we need to graph is just one cycle. Okay, let's try one more to solidify this. So number 2 here, y equals -3 times the tangent of 2/3 x. So again, this is y equals a times the tangent of bx, which means our a value is -3 and our b value is 2/3. So we're going to use our b value of 2/3 to calculate the period of this transformed function. The period is going to be pi divided by b, which is pi divided by 2/3. To simplify this, we're going to keep, change, flip. So keep the top, pi over 1, change the division here to multiplication, and multiply by the reciprocal of the denominator. You'll flip that bottom. So overall, we're going to multiply across, and that means the period of this function is 3 pi over 2. Okay, so since our period is 3 pi over 2, now we have to figure out what that means for our asymptotes. This is a transformed tangent function. So tangent function, tangent has an x-intercept at 0, and you're going to go half the period in either direction to get your vertical asymptotes. So we are going to have vertical asymptotes at either end here. We'll have one over here and one over here. And the distance that you go away to these asymptotes is going to be half your period. So half of our period is that pi over 2b that I gave you up here. And so we're basically just going to take half of what we got for our period. So that's going to be 1/2 times our 3 pi over 2. That means our vertical asymptotes are going to be 3 pi over 4 units away from 0. So from 0, we'll go to the right by 3 pi over 4 units, and we'll go to the left by 3 pi over 4 units. So that's where our vertical asymptotes happen. And um, I did your x-intercept kind of at the beginning because tangent always has an x-intercept at 0. Um, so really now all we have to do is figure out whether this thing comes down left to right or up left to right. Best way to do that is to pick an x value and plug it in. I'm going to pick the positive x value halfway between our x-intercept and our asymptote. Halfway between 0 and 3 pi over 4 is 3 pi over 8. So that's the value that I'm going to plug into our function. So if x is 3 pi over 8, I have to figure out what y is. So y is going to be negative 3 times the tangent of 2/3 times x, which here is going to be 3 pi over 8. So our y value is going to be negative 3 times the tangent. Let's see, our 3's are going to cancel here. This is going to be times the tangent of 2 pi over 8, which simplifies into pi over 4. So negative 3 times the tangent of pi over 4. Well, the tangent of pi over 4, again, we have our pi over 4 on the unit circle here. To do tangent, that's y divided by x. So our tangent is going to be the y value at pi over 4, which is root 2 over 2, divided by the x value at pi over 4, which is also root 2 over 2. Root 2 over 2 divided by itself is 1. That means when x is 3 pi over 8, y is negative 3. So I'm going to come up here. When x is 3 pi over 8, y is negative 3. And I'm going to use symmetry to help us. I know that on the other side, negative 3 pi over 8, symmetry is going to push this to the other direction. So I'm going to go up 3 instead of down 3. And this function goes down from left to right. And that is one cycle of the function y equals negative 3 times the tangent of 2/3 x. All right, so I hope this helps you with transforming tangent and cotangent graphs. I'm sorry it was so rushed today. Let me know if you have any questions as you're studying this weekend. Have a great weekend. Happy studying. And I will see you on Monday for the test.